A warm welcome to all. I take this opportunity to welcome you all for the international webinar on AIoT, the future of IoT, organized by ThickNess Learning Community. I welcome our young and energetic speaker of the day, Mr. Karthikeyan Prakash, co-founder and chief product officer, IoT AI enthusiast, Phase Open, New York, USA. I welcome you, sir.
And these neurons get fired, meaning when I say fired, it's basically sent an electric pulse to trigger when something is happening, right? When I touch something, when I touch myself, there is something, these nerves and the sensor skins and everything sends the data to the brain. And the brain has neurons which actually sparks, which actually uses the electric pulse, and then it understands. It either asks me to take out the hand or it asks me to touch more. All those things are happening due to that, right? Similar way, we are building a neural network which has got multiple layers of neurons, and what we do is we feed in the data and teach it. How we teach the kid, right? When a small baby is born, the baby also has got a AI, like a brain, right? But baby doesn't know anything. Baby comes with a very preliminary information like crying, all those things, right? But beyond that, if baby wants to learn what it needs to learn, it needs to be fed in a lot of data. The data, how it comes, either it comes through the sensors or it comes through the already matured artificial intelligence data set, right? That is our parents or all those people who already seen this data. We call it as an experience, right? Similar way, for any neural network that we are building through ourselves, like a programming, what we do is we take a huge data set. I'll take an example of face detection. That's what I have. Very simple face detection. That's very common use case that people are using right now, artificial intelligence for, even on the cameras directly, right? So what it does is we take lot of human photos, right? Lot of human photos. We mark this is the face. We put a box around the face, and then we feed into the neural network saying this is face, this is face, this is a face, this is a human face, this is a human face. And what it does is the neural network goes to that level. I'll go deep into how the neurons actually propagate and then how he understands and all. So basically this is the high level how it learns. You feed in the data, it understands, and then it improves its accuracy, right? Over a period of time it improves its accuracy, and once it reaches the accuracy of 90%, 95%, we put it for work, take the model, put it for working. So what we do, we feed in any other data to this neural network, and it starts predicting, okay, this is face, this is face, these many people are there, that many people are there, from the programming, right? And remember, why we cannot do a simple logic, right? Why we cannot write a simple mathematical logic to understand, okay, this is a face, right? The main issue with simple logic that we had is because it was able to predict only through known faces, right? I feed in, let's say, 10 people's data and then tell a logic, this is the face. When you show somebody new, not from this 10 people, and show their face, the logical method tend to fail, because it just your logic is like trained only on those 10 data set, right? But the neural networks, what it does is it kind of creates its own weights or bias, or maybe you can call intelligence, right? So in mathematical terms you call it bias. There is a formula how it creates its bias and then the weights, but that is how it learns basically, right? Once it learns, you train with 10 people, now you bring all new 10 people, still it will be able to predict. Okay, it needs to be closer to what 10 people you have trained, but it will be still able to predict. So most of the time the AI was developed in past 5 years, but it all running on cloud, because it needs the neural network models are so heavy. It is CPU hungry, it is GPU hungry, it needs a lot of processing capacity to run the models. Now the trend is shifting. Now we are actually bringing the AI on the edge. When I say edge, the AI moved from the cloud. Let me go to previous. The AI moved from the cloud to the gateway. I'll take the pointer. Cloud to gateway. Now, even from gateway, the AI is moving to things or devices. That's the whole topic we are going to see today. Why, how it is moving, and some examples. And I also have some live demo for you all. I'm running a neural network model on a microcontroller, right? It's very constrained device. It doesn't have a sophisticated memory. It doesn't even have a EE prompt to store anything, but I'm still running a neural network on this device. So I'll show you the live demo. But right now the trend is the AI is moving from here to here. That's what happened, right? I'll also explain you why it is happening. So now I'm going to take a pause and I'm going to play a video. This is not my video. It's basically a video that I saw from YouTube for the people, for the students who are joining here. It just to give you a sense what it is happening in the world right now and how it is changing. Let me click on this, play the video. So I'll stop it here and then I will quickly move to my presentation. This is just to give you all an idea what is exactly happening, right? I'll move to this particular use case, kind of a chart that I have here. So this chart, you can see what exactly is happening on the IoT space, right? Now we will take some examples, real-time examples, right? Let's take a camera, right? Most of you would have seen a CCTV cameras installed on the road, right? People use it, our police department use it to monitor what's happening over there. But now these things, these what should I say, the vision AI cameras, what it does is it takes the video, sends it to the cloud, and then the analytics, AI, and everything happens on there. Or maybe you will have some human just sitting and watching the video. And think about this, how much it would be difficult to put so many people over there, humans over there, to just monitor these cameras, right? This is not a productive way to do it. And that's the reason the AI is coming into the vision, computer vision, right? It coming into the cameras directly. And how it is happening, now think scenario, a simple scenario, right? You want to know how many people have crossed a particular street. This is a very simple use case. Now there are two options that we have. One is you record all the video or stream all the video directly to the cloud and you have a human sitting there who is actually physically counting all those things. Or you develop a neural network which can do the face detection and then you put it directly on the camera itself, and then the camera says, okay, today I have seen 10 people who are actually crossing the street. How cool it will be, right? The same thing is happening right now. Cameras, again, it's a constrained device. You cannot have a sophisticated AI running on it. So mostly the AI, whenever we move it to the edge, we make it for specific use case. We don't make it like a general intelligence, right? Maybe face detection. What if we develop a model which can detect the accidents, right? If there is accident that happening, the camera actually understands that's an accident, immediately sends an alerts to the ambulance, and then ambulance comes to that location, right? So those all possibilities of combining this IoT with AI. And there is a category called future, but I would say that's happening now. It's not a future, it's the old image, right? But it's happening right now. You already seeing the autonomous cars here in US. Maybe in India it's not there yet, or maybe in other parts of the world it's not there yet. I have seen in China, I have seen in US, we have autonomous vehicles. I have personally sat inside an autonomous vehicle. I have tried like Tesla's auto driving functionality, self-driving functionality, and it's like amazing because it understands the road curves, it understands the lane, it understands if there is a vehicle in front of you. And even in China you have electric bus which does the autonomous driving or assisted driving, right? And natural language processing is common all over the world. You have Echo devices, you have Amazon devices, you have Google devices, and even your phone has got its own the voice assistants, natural language processing, right? You ask it, okay, what's the weather today, and it says you what's the weather, right? So those all things are possible with combining the IoT with AI. So I'll quickly move on to how this AI works, right? And what we are exactly going to do today. So the neural networks, as I said, it has got a network, right? Input network, and then it has got a hidden networks, and then at end it called as output network. For simplicity of other people understanding and the wide variety of audience over here, I'm not going in depth into the neural network, how it works, but I am also including a YouTube video which will be posted in the description that you can use to go and see how neural network works, because somebody might already know, so I don't want to explain again. But people who are new to this, please do watch this video. You will get a lot of idea on how the neural network works, right? So this is what I called as neurons. The every dot that you see here, it's called neurons. When you train a model, that if it's a solid, vertical, diagonal, or horizontal, and then you pass in the image, it goes through each and every neurons, and every neurons assigns its own weight, right? It says, okay, this is this, this is this, this is this, and I'm 50% confidence, I'm 100% confident, right? It's all about confidence score when it comes to the AI. And when it comes to the output layer says, based on how many neurons told me, I think this is a horizontal, right? All other are gray. Basically, it will say 10% solid, vertical is 10%, diagonal is 10%. But most of my neurons, majority of my neurons told this is a horizontal. The black dot, black, what should I say? The black boxes is horizontal, and that's the reason the neural network says predicts that it's an horizontal, right? It won't give you the decision. It always predicts. It always predicts. It's up to us to write a logic on top of it to make it like a decision, right? Whether you want to take it horizontal or you want to say diagonal or horizontal, it's up to us to take it. Now, for today's webinar, I'm going to take a TensorFlow framework for our the demo as well as the explanation, right? TensorFlow is a pretty famous framework released by Google, and it's an open source framework. They made it open source to bring in a lot of community inside it, right? So TensorFlow is a framework through which you can write a lot of neural network. You can train your model. You can convert your model into TensorFlow Lite. So what is TensorFlow Lite? It started with TensorFlow Mobile and then evolved to a TensorFlow Lite, basically. Now, as I said, these neural networks which are trained needs a lot of processing power, a lot of memory to run the models, right? Now, the TensorFlow Lite, what it does is you can have a specific use case and convert these TensorFlow models into TensorFlow Lite models. Basically, what it does is the PB files, the weight files will get converted into PB Lite. Basically, it's a weight Lite files. And in maybe in the weights, you might have like a floating point, meaning the weights are basically like a numbers, right? It assigns a number. Let's say 128 dot maybe 1 2 3 4 5 6 7 8, right? When you multiply with that, and then you will get a very very precise output. But when you go to the TensorFlow Lite, it won't be a floating point, it may be a 16-digit integer, or maybe it becomes a total a rounded off number. But what is the trade-off of doing that? The accuracy may drop, but there are a lot of ways how we can improve the accuracy in TensorFlow Lite as well. So what we do as a process, we make a TensorFlow model, we convert that into TensorFlow Lite, and then we test the accuracy on TensorFlow Lite, and then we move towards deploying it on Android, iOS, mobile phones, or maybe Linux embedded devices like Raspberry Pi, or a microcontroller that I have for today's demo, right? Those all things are possible with with the TensorFlow Lite model. So what happens when AI meets IoT, right? As I said in the starting of this webinar, these are called as like superpowers of innovation, right? It triggers a new and enhanced products. What I mean by new and enhanced products, you might see something like I'm not sure how many people would have seen this. Please go and watch the live video that Elon Musk unveiled his next product. His company is called Neuralink, and yeah, he owns three more companies as well, like Tesla, SpaceX, and other things. Neuralink is boring company, and Neuralink is one more is startup, right? So they are coming up with a robot. What it does is it opens your skull. Basically, it's very scary, but closely watch that video. Okay, it opens your skull. It puts in the chip on your head, and then the electrodes goes into your brain without damaging your brain. Okay, so now what these electrodes does, it reads all your brain signals through Bluetooth. It sends all the data to your mobile phone, right? And think about the possibility if it happens, right? What if you don't need to go to a school or a college, just buy a memory card and then put it inside and then you get all the knowledge, right? Yeah, I'm just being like imaginary here, because it can happen as well. It can happen, and it is happening. In the live video, live product unveiling, Elon Musk showed, he used a pig as a example. So what he did is he inserted that product inside the pig's brain, and they were able to correctly predict if the pig is eating or not, right? If it's touching the nose, if you touch its nose, it kind of gives a beep sound. So that's how they made it predict. And also based on the brain signal, they started predicting how it walks, what is the position of its legs. And as you can see, the camera based prediction and then their brain signal based predictions, those are like coming together, like it's equal and it's precise, right? Now it can happen in future. In next 50 years, you might see people having a small chipset on their brain, and then it's able to read, write, and everything, and you don't need any mobile phones. We don't need to do anything. We all sit there and then we think, and we all come together on the brain itself, right? This is a huge possibility, right? And then increasing the IoT scalability, right? The scalability, when I talk about it, when you make it more costly, when you have a power supply and a lot of requirements in installing these products, it cannot scale. I want to buy a IoT bulb, a multicolor bulb that I want to use it on in my home. But what if it's 1,000 rupees in Indian cost, or maybe $10-15 in US cost? I don't want to do it. What if it's only $1? What if it's only 70 rupees? It will go into more people's hands, and then you will be able to get a lot of data, and you can also make a lot of scalable products that goes in millions
Karthi,
and billions of people's hand. Yeah,
please check your chat box.
sure. Hello. Screen sharing, please. Screen sharing option. Yeah, I got it. Thank you. Let me know when I can start. Yeah. All right. So welcome back after the intermission. Now we discussed about increasing the IoT scalability right before we went for the intermission, and I will jump into the better risk management. Right. Example: when I say risk management, I don't want to go talk about like a big use cases like how companies can reduce their downtime, all those things. Right. Those are possible with any technology, and companies are ready to put in a lot of money into all those things. But think about the human life. In our human life itself, what if there is a camera that, as I said, there is a camera that can detect the accidents, and it can just call the ambulance right away, send a message to the ambulance with the location coordinates right away after the accident happens. It sees the accident. You don't need people to see that accident, call the ambulance, or someone may call, someone may not call. All those things are there. So basically, those kind of risk managements are possible when you have AI meeting the IoT, right? It comes together all together, right? Now, how to implement this is something I want to cover mostly after this. Right now we spoke all theoretical which are available out in the market, right? You can understand that, and maybe there are videos that is much better than what I have explained over here. So I will more focus on how to implement, what you need to do right now if you want to explore what is AI, and I want to put AI on the edge, what I needs to do, right? So first thing, you have to choose the right hardware for your application, right? Not all the microcontrollers, not all the processors support the neural network processing, right? You have to choose the right hardware for your application. Example, you can choose the Arduino. Again, there are a lot of models in Arduino. You have to pick the one supports the neural network TensorFlow framework that you can put the neural network into. So today I have chose the Arduino Nano BLE Sense. This is basically a Nordic chipset based microcontroller. It's Arduino platform. It runs Mbed OS RTOS, but still it supports on the Arduino platform. So now we are going to run the neural network model on this microcontroller. As you can see how small it is, right? If for a sake of finger, right? For the size, you can see how small it is, right? I can run this on battery as well. Now, right now I connected it to USB because I want to feed in the program inside this, right? So now you have to choose right sensors as well. Now the Arduino Nano BLE Sense comes with lot of sensors already connected to it. It has got microphone, IMU, all the GPIO, so you can connect whatever the sensors you require. But it would be good for you to just get started. It has microphone, it has the IMU sensor if you want to do any motion related uh, task. Now for the other processor or other DIY board that you can buy and try out is the Raspberry Pi, which is $35, which is very easy for you all to buy. It's easily available everywhere and it's cheap. So you can buy that and then you can start writing some Python program, running some small neural network model on the Raspberry Pi, because you can connect USB camera also to it and come up with the camera applications, like you can do face detection and all. You can still use the Nano BLE Sense to connect to a camera. This is capable of doing the face detection, right? But this is more like a constrained device. It is cheaper than the Raspberry Pi itself, right? When you go in a big scale. Now let me talk about the framework. As I said, choose the TensorFlow Lite. That is something suggestion from my end. There are a lot of frameworks out in the market. This is just my suggestion. Go for TensorFlow Lite because you have got a lot of community around the TensorFlow group. So if you have any doubts, you will have a lot of people to support you and help you. And then you can also what should I say, examples, right? There are a lot of examples out in the GitHub. You can go pull it and directly start running it instead of training your own neural network. See, the other thing is you can develop the neural network. If you don't know how to do, first you want to start, for the students who wants to just try out something, you can use a pre-trained model. Somebody would have trained that neural network with their data, and they will put in the model into the GitHub. So what you can do is you can directly go there and you can pick that model and start running it on your microcontroller. Deploy and test. Artificial intelligence and IoT, on theory itself, it's all good, right? In theory, we can talk about how chip goes into the brain, all those things, they all look good, right? But how you can exactly understand what is IoT, what is AI, you can understand only by doing it, right? You have to get hands on the product, on the devices, and you have to do it yourself. That's why we call it DIY, right? Do it yourself and understand it. Even though I started my career as a hardware engineer, instrumentation engineer who does hardware assembly as well as the software on top of it, but even now, even after we scaled, I moved to chief product officer position, I still have my own hardware lab right next to me. I also keep trying new things, right? Without trying new things, the human will not evolve. The human community will not evolve. That's the reason we need to keep thinking. We need to keep, trying it out. So for this is more like what kind of hardware you can use for AI on the edge. So there are some information that I have here, which might be useful for the people who are a little bit advanced in the AI, who can understand the AI very well, right? So most of the time people use CPU, GPU, AI processors. There are dedicated AI processors by NVIDIA. NXP is also planning to release an AI processor, dedicated processor, which has AI processor inbuilt into it. So there are two things we see in the AI processor, which is TOPS and the TF LOPS. That's basically TOPS is a tera operations per second, meaning it can do 1 trillion operations, integer, float, whatever it could be. It can do 1 trillion operations per second. Remember, the neural network is always a parallel computing. That's the reason we cannot do it with the CPUs. There is a blog that I have written. What's the difference between CPU, GPU, and TPUs? There is a TensorFlow processing unit, right? Google has came up with its own processing unit to run the TensorFlow models. But why we are not running a OS, right? The Windows OS or Linux OS on GPU, we can run, but still why we are not using it in a large scale? Why we are not able to run a OS on AI? So I have written a detailed blog. I can also put that in the description in the video. So you can go and read about it to get better understanding what's the difference between CPU, GPU, and AI. Why AI people, artificial intelligence, machine learning people use GPU and AI processors or TPU rather than the CPU, right? I have written a detailed blog on top of it. And again, TFLOPS is basically a tera floating point operations. It's 1 trillion, usually single precision. And single precision, when I say it's, let's say the weight files are 10.1, 10.2, like that, right? And when I say the tops, it's basically it can do float as well. It can go up to 4 or 5 digits after your integer, right? Now, today for demo, I'll quickly jump into the demo. I have a custom Wakeword detection model. Before I go in, I'll explain what is Wakeword for the students here. Wakeword is nothing but you would have used in your life for sure, right? You take your mobile phone, you say, hey, Google, right? Or you say, Alexa, turn on the light, right? These are called wake words. So the device around you is always listening to you, but it is not doing anything because you are not talking to that device. To understand if you are talking to that device, we added something called wake word. In maybe in future, you think that you want to talk to the device and the device knows that you are talking to it. That's all the future thing, right? Maybe in 5 years when we come back, maybe we will see that kind of technology coming up. But think about this now. If you want to interact with the device, you say wake word. Wake word is like a name for you, right? When we are sitting in a crowd, I say somebody wants to talk to me, I say, hey, Karthik. When I hear Karthik, I know that they are talking to me, and I turn here and I also look here. Similar way, the wake word works. You say, hey, Google, or maybe Alexa. It understands, the device understands you're talking to it, and then it actually starts working. And as I said, I have Arduino Nano BLE Sense. Hope my video is also visible, just to make sure. Yeah. So Nano BLE Sense that I'm showing right now, I also have this deployed, and I'm going to use the TF-like framework and Arduino plus Mbed OS for today's demo. I will quickly shift into my Arduino programming. Yeah. So here I have the Arduino IDE, and this is basically, there are a lot of examples available, right? You don't need to worry about, why it's so complicated. I'm going more complicated into software for the students. Example readily available. Go to GitHub and just pull the code, and then you can understand very clearly what you need to do. Okay. So now I have an example program here. What it does is, I'm using an example called micro speech. What micro speech does is basically, it is a framework to run the Wakeword detection models, right? So I'll take example for the students. I'm directly going into the examples. When you install a library called Arduino TensorFlow Lite, you can see a lot of examples over here. Just pick micro speech example. I have the micro speech example already opened here. So there is a model.cpp. Let's go here. Where it is, model.cpp. I'm already here. Oh, okay. So basically, when I talked about the weight files, when I converted those weight files, it will be in PB file. When I convert it into a light model, and then I want to put it on microcontroller, it will be converted into C++ code, because you know that Python and maybe Node.js, all those programs are called as a runtime compiling programs, right? Those are called as runtime compiling. But if you want to go to microcontroller, you cannot do compiling while running the microcontroller, right? So you have to compile the program, take the binary zeros and ones, and feed into the microcontroller for it to understand. And it has also got a very constrained space to store all those things. So that's the reason we put binary files. Now, this model, I think when you train, it will be like 30, not even 30, it will be more than that, 100 MB, 150 MB of weight files. Now you don't want to have that level of space in the microcontroller, right? You cannot have a SD card for this microcontroller. So now what we do is we convert it into CPP files. Now all the weights are converted into this format, right? These are weight formats. And this is what getting converted into your CPP code and getting burned into the microcontroller. Other than that, you have all the logics also written on top of it. I can tell you one example what happens when I do it, right? Let me take the program. The logic. So this example, what it does is, when I say yes, it will turn on the green light, and when I say no, it will turn on the red LED here. It has got its own LED, so it will turn on and turn off accordingly. So I'm going to show that example. Okay. Command responder. Command responder is the file I want to go for. Give me a second. Recognize commands. Yeah. Maybe I will start searching it. LED. Find. Yeah, for the sake of time, I'll just quickly jump into the demo. So what it does is, there is a logic inside. What it does is, it basically understands if I say yes and if I say no, and then it compares it. So I'll quickly start uploading it. Let me see if I have chose Nano BLE connected to my laptop. I chose the Nano BLE, so I'm going to click on upload. So when you click on upload from the Arduino, for the people who are new to Arduino, what it does is, it first compiles the program. It sees that if libraries are good or not, then it goes and then it starts putting that code into the controller. So I'll just hold it here to show you. So it's compiling right now. Anyway, once compiling is done, you will see in the screen here. Booted successfully. It has booted. Let's try out the example. And remember, this is an example, and the model has a very low accuracy. When I say accuracy, it cannot predict that much precisely. Let's try out for today's demo, right? Let's say Yes. Yes. No. No. Let me reboot this here. Let's see what it shows in the serial command. And it says heard unknown, right? Yes. Yes. As you can see, it turned on the green LED actually. And when I said yes, it said heard yes, right? That's because I'm talking something else right now and it says always it recognized unknown, right? It's not showing me any yes. Let's try no. No, no. As you can see, the red LED blinked and it has recognized no. So this is the very simple example of the AI on the edge. What if I make it as a small bulb, right? And then whenever you say yes, it needs to turn on the bulb. And whenever you say no, it just turns off the bulb, right? So this is all the possibilities by doing this one. Now I'll quickly show what I have did with this. What I did is I trained my own neural network, or we trained our own neural network for the custom Wakeword detection. I will not go in depth. I'll just open it here. I just use the same example, but we have modified it a little bit. So I'll show you how we have modified it, right? Let me do this one split screen. It'll be easy for us to understand. Okay. Anyway. Okay. So here, the model that I showed you all previously, let me go to model.cpp, right? So as you can see here in the example program, the model.cpp model. Yeah. So it starts with 0 cross 20, 0 cross 0, 0, all those things, right? These all because, what should I say? Its own weight files, the model's weight files. Now, if I quickly shift to my program, here you can see it's 0 cross 1c, 0 cross 0, 0. This will vary. So just I'm showing example. I'm not doing magic here. The model is different. I replace the model and then I change a little bit of logic over here so that it works for my use case. And then, the example has been modified. So that this model is trained on a TensorFlow, full-fledged TensorFlow, and then we converted it. The same way right now, let's go ahead and click on upload. Let's see if it gets uploaded properly. It's compiling the sketch. I'm just giving a pause here. I'm compiling the sketch. While compilation is happening, even the microcontroller runs the previous program only, right? When it starts uploading, that's time it changes. So meanwhile, if you all have any questions, please do post it on the chat so the team can take those questions and prepare themselves and I can start answering those questions. I want to keep it more interactive. Please do ask a lot of questions because I don't know what exactly you want to understand. I can go all the way more technical or maybe I can talk about the basic concepts. So as you can see, it booted. Here it says 6 seconds. Let's go and open the serial command and clear the output and reset this. Yeah. So I have trained this for a custom Wakeword, basically, the open door. Open door. Let's try it out. The accuracy is low pretty much. Open door. Yeah. As you can see, the green LED came and then it said, I said Wakeword. Wakeword is nothing but my open door. Open door. Let's try it out. Open door. Right? And you see the Wakeword, right? So I trained this in such a way that whenever I say open door, it needs to do something. So I can use this for deploy it on any product and then I can just open the door, close the door, all those things. So those are possibilities of running the neural network on a microcontroller. This will cost you very, very cheap when you want to go ahead and do it, right? In a mass production. That's the reason we developed this TensorFlow Lite on a microcontroller. So with that, I'm stopping my demo. That's it, the demo from my end. Now I'll open it for the questions. ThickNess team, you can take it forward. If there is any questions, I can answer right now.
What are the roles of RF engineer in AIoT and IoT?
Okay, okay.
Person
That's
from
very
audience.
interesting. Yeah, very interesting question. Very interesting question. RF engineers play a key role in AIoT and IoT. The one point which I missed mentioning about it is because it's not about the cost for running the constraint devices, right? It's not just the cost of the product, but also it needs to run on a battery, right? It needs to run on a battery. Now it needs to run on a battery. You cannot run on Wi-Fi, right? You cannot run on Wi-Fi. Now this Arduino Nano BLE Sense, now I have the USB connected to it. But what if I remove it and put it in a product? How this microcontroller will communicate to my mobile phone, right? There needs to be some sort of RF communication that needs to happen. It has got BLE, right? Bluetooth Low Energy inbuilt into it. As you can see, there is a small antenna over here, which talks about what should I say? Which actually helps us to communicate directly to the mobile phone, right? It has the RF antenna and other things. And not just this, there are a lot of technologies in the RF that is coming up for the specific AIoT and IoT use cases. Something called ultra wideband, which I started exploring a lot after your iPhone 11 already has ultra wideband chipset into it. Samsung recently released its Note 20 series. It has got ultra wideband chipset, right? uh, uh, People design a new RF technology just to put it to these IoT devices because the existing RF is not supporting the use cases what we wanted to do. Now, why we went for UWB? Because we do outdoor positioning using GPS, right? What if I do want to do like indoor positioning? What if you go enter into a supermarket and you open their app and you want to pick up, let's say, milk, and then it tells you exactly how to go and pick up. You don't need to go roam everywhere. It tells you, okay, go straight, go left. But again, GPS cannot work indoor because you need the GPS signals, so it cannot work indoor. So now Bluetooth again cannot work because the range is good, but the accuracy is not good, right? It doesn't know how much closer you are to the maybe a place, right? Maybe a sensor where it is. Now the UWB came into picture where it can precisely triangulate and understand where you are, right? And then it can also run on a battery. It's a very battery optimized RF. So RF engineers have a lot of roles there. 6LoWPAN. There is the IPv6 protocol that's coming up. There is a special antenna need to be designed. When all these things we are designing products, it's all beautiful, but again you need to design the RF in such a way it can communicate to the gateway or other things, right? By itself, if it's like a human, I will compare it as a human, right? You know, you are super intelligent, but you cannot express it, right? You are intelligent, but you cannot talk to people, you cannot explain to people what happens after that. There is no point in having intelligence, right? That's the exact thing. RF engineers will have a role here. RF engineers will make sure the intelligence can communicate to the world, right? And there is a huge opportunity over there. Please go and explore. What is UWS, what is coming up, what is BLE, and what is BLE Bluetooth 5.0. What are the technologies that are coming up in the AIoT and IoT? Any other questions?
What are the recent researches are going on in this AIoT?
Yeah. So one technology, as I mentioned in my previous answer, the UWS, it's basically ultra wideband, right? It's a new technology that's coming up. And remember, when your mobile phone has got UWS chipset, it's so serious. And iPhones has got it already, right? It's very serious, dead serious that people are moving into new RF technologies, right? So in AIoT, the other thing I mentioned about Neuralink, please do watch. You will be surprised to see some animals has got the chipset installed into their brain. right? That's happening. Autonomous driving is again a huge area that it's improving as of now. In India, it's not there yet because our traffics are not regulated, our roads are not regulated. But other parts of the world, like developed nations, things are moving pretty much faster. And the autonomous cars, it's not sending the data to the cloud, and cloud is deciding whether you need to apply brake or not, and then the data comes to it, right? It cannot happen. You need to stop the car when you see something is in front of you, right? And that's the artificial intelligence plus IoT coming together, right? When it sees something in front of you, it just applies the brake immediately because it has got cameras, it's seeing, it's sensing, and it's also taking decisions all the time, right? That's the new trend that's happening in the AIoT. And you will see a lot of applications that will come in future as well, which will combine this artificial intelligence plus IoT. And I think it cannot be splitted into two. We cannot call it AIoT and IoT, right? IoT itself cannot be a kind of as I said, to come, related to the real life example. Let's say you just have a Hulk, right? In the Avengers role, you just have a Hulk. Hulk can do certain things, but Thor also can do certain things, right? So now you need both of them to fight, right? So that's the same thing. IoT itself can do something, but it cannot be scalable. There are a lot of limitations and other things. So when AIoT comes together, it will become a huge superpower. And I think that will be the future. And mostly when I say IoT, it will be AIoT, artificial intelligence included in it. So that's what I'm thinking that's going to be the future.
How AIoT is used for medical applications?
Yeah. So example is smartwatch, right? I'm wearing a smartwatch right now, correct? So, but the smartwatch itself cannot be a kind of it has got heartbeat sensor, it has got like all IMU sensors which tracks how much I'm walking, all those things, right? But it's all fine. But what it can do beyond that, right? If you see, Apple is doing a lot of research into this smartwatch field, right? They got Apple Watch. Now, what if this can tell you, hey, your health is not good, you're going to get a heart attack in next 1 month, so you need to do something, right? That's a medical, what should I say, it's a next milestone in medical. Before you go to the hospital, it will predict you. So right now, most of our medical are basically, what should I say, it's kind of a response. You got something, and then you go to the doctor, and the doctor does something to stop some extreme things to happen. You got a fever, you go to a doctor, and then he gives a medicine to recover back, right? What if we can predict the things? What if we can tell, okay, you do this based on your past activity, you ate this, you did this, you went here, you did this, and finally, based on your data, your body data, I feel like you have this problem. You have this problem. So I see in the medical field, without going into the much complicated use case of having electrodes inside your brain, a very simple use case that can happen in your life is that when you buy and wear a smartwatch, it can start predicting your health conditions, right? That's a very big milestone in the medical field. And right now, because of COVID situation, a lot of medical field is transferring into a telemedicine where doctors are not meeting you in person, and he needs to have some sort of data to analyze, right? When you go to a doctor, he puts the thermometer and he does the respiratory checking and all those things. But what if you are not meeting in person? How do you give the data to the doctor, right? So that's where this smart fitness bands, smart watches, and medical equipments will come into picture, where it will be able to send that data to the doctor. So you may not even need to go to the hospital, right? In future, you just sit there, you share your data, and somebody sitting there will tell you, okay, this problem you might get. So that's the next big milestone that I see in the hospital use case or medical use case, I can tell. Yeah.
Next question. I'm
Mhm.
new to this field. I want to know clearly how to write the code and embed it in the device.
Okay. Good question, maybe from a student, I guess. So what you have to do is, as I said, very simple. First, go watch a lot of YouTube videos in terms of DIY, right? The two platforms that I said, Arduino, Nano BLE Sense, and then your Raspberry Pi, you can use those, and then you can write some code on top of it. I can go in depth and teach you as well, but the best thing is have your GitHub account, and know the basics of writing a program on Arduino, and then you can get into IoT first. First, start controlling LED, start controlling some light, relays, actuators, all those things, and then move into the AI. There are pre-trained models out in the market. You can just take that model and run it directly over here. First, understand the basics of AI, because people start writing, machine learning code without understanding the basics. So try to understand the basics if you are new, and that's the good thing that you can do for your career, right? Your whole career. Understand the basics, how the AI works, how the IoT works, and then take simple steps. First, start with Arduino, start with Raspberry Pi, write a simple code to control GPIO. Maybe try to send a command from mobile and the LED should turn on in the microcontroller, and then you can go for it, right? So that's a
Next
quick,
question.
yeah.
Next question. Do you think that India will make such new technologies which should be same as the foreign countries doing right now?
Absolutely, there is no doubt at all that India is catching up. And I don't know how many of you know more, like the recent iPhone models, iPhone 11, iPhone 7, and everything is getting manufactured in India right now. It's moving from China, right? And Indian government is also doing a lot of initiatives. Central government is doing a lot of initiatives in terms of promoting these startups who are doing into this technology. The main problem in India, I would say, is in the education system, that you need to start doing all these things while you are studying, right? When you are studying the theoretical questions, you have to also try to do it in practical, right? We have to encourage the practical learning. So buy one nano BLE, buy one Arduino, buy one Raspberry Pi. Maybe if you don't have the budget, you just go and ask your college to provide a Raspberry Pi or Arduino, and then you can start programming, start doing it, do your projects yourself, and I'm pretty sure you will be able to see what kind of products you can develop. And India, yes, there are a lot of things happening in India right now.
Okay, last question. Do Indian government spend that much to make such IoT and new technologies?
Sure. I'm not from government, so I cannot say how much they are planning to spend. But what Indian government does is they promote the startups who are trying to make these products, right? I have seen some startup programs. I personally applied for those startup programs. What this government does is it just bootstraps you or maybe pushes you to develop the product. Government itself won't do anything. Got it? Maybe the IITs, they feed in money to the IITs and everything to make the products. But what you have to do is you have to understand that you have to do something and go and ask government for help you to basically enhance your product. And government specifically, there are a lot of Startup India programs that you can go and apply for it. Yeah. Any other
Okay,
question?
running short of time.
Okay. Okay, so if anybody wants to communicate to me, or if you have any further questions, what you can do is I'm available on LinkedIn. You can just go and search Karthikeyan Prakash. I will also ask ThickNess team to put in my LinkedIn account. You can ask the questions, or you can reach out to ThickNess team directly, and they can also transfer the questions to me, and we can connect through email, LinkedIn, WhatsApp, whatever it works for everyone. Okay, thank you all. Thank you for thank you ThickNess team for giving me this opportunity to give back to the students community. Yeah.
Now I request to Dr. K. Shanti ma'am give the vote of thanks.
Once again, I extend a pleasant good evening to all. Indeed, it is indeed a great honor and privilege to propose the vote of thanks on this wonderful occasion, international webinar on AIoT, the future of IoT. First and foremost, I express my sincere gratitude to young and dynamic speaker of the day, Mr. Karthikeyan Prakash, co-founder and chief product officer, Face Open Newark. Despite his busy schedule, has found time to grace us with his wonderful lecture. Thank you very much, Karthikeyan.
Thank you, ThickNess team.
I also express my heartfelt thanks to our advisors, Dr. R. Dhanasekaran, Dr. M. Nirmala, for their valuable contribution, encouragement, wonderful guidance and support. I'm also very grateful to our technical team for all support and arrangement to make this webinar grand success. I express my special thanks to Dr. Izdari Mas Iza, Dr. Gang Kom, Dr. Razali from Malaysia to make this event as an international one. Finally, I would like to thank to our sponsors, Inimus Technologies, Coimbatore, RR Nets at Chennai, who supported behind the success. Not but not the least, I would like to thank all the participants from national and international for showing their interest in this webinar, for making this event resounding success. Thank you very much for this wonderful opportunity. Thank you.